Hi there, it's Karen. Welcome to Mini Math Lessons, and we are working with statistics again, still with regression. And so I'm using Classpad.net. Be sure to get a free account so that you can create your own activities, and especially if you want to save the work you do on this activity or save it and modify it. So that's something to keep in mind. The activity link is provided in the description of the video, and here's what you get. So this is an activity adapted from the Fostering Statistical Thinking, which is a Casio technology resource. And basically it has a table that includes the planets. We have included Pluto, but technically it's not a planet anymore. But here's the planets, and basically what we have here is the distance from the sun and how many days it takes each of those planets to orbit the sun. So you'll see here Earth, 365 days, that's where our year comes from, and it's 149.6 kilometers. So over here distance is in kilometers, this period is the days. Okay, so that's what this table is showing, and students are going to determine if there is a relationship, and if so, what type of equation would fit that data. So they're going to be looking at regression models. So the first thing they're asked to do is basically, do you think there's a relationship? I mean, one thing we can say is it seems that the further away you go, the more days it takes. So that's sort of a relationship. Is it constant? Is it exponential? That's what we're trying to look at. So the next thing they're going to do is actually make a scatter plot of this data. So we're not going to use the names of the planets. We're simply going to use the data here, and they have in the first question kind of thought about which one is dependent on the other. So which one's the independent variable, which one's the dependent, and hopefully they've determined that distance is our independent and dependent is the day. So the distance determines the number of days. So once they do that, they're going to select their columns, they're going to go into graph, they're going to make a scatter plot. And now they're going to visually be able to maybe make some predictions about what kind of relationship this was. So again, questions over here that they're going to be answering, and there's places for them to write their answer. And so they're going to look at it and say, well, is it linear? Is it quadratic? Is it exponential? And they're going to hopefully see it's maybe not linear, but maybe they can't see that. So maybe they might think it's linear. So those are the kind of questions. And then what they're going to do next is try out a bunch of different models, right? So that's the beauty of Classpad, is you can do these very quickly. So they're going to go back up here where these two columns are selected. And now we're going to go, instead of graph, we're going to go into regressions. And what it suggests that they do is just try a couple. So let's just do a linear and see how it fits. Not so awesome, right? And remember, you can move all these things in Classpad here. And if you look at more, it kind of gives you a feeling how good a fit that is. So then let's keep doing some regression. So I'm just going to do a bunch at a time. Now they could look at them individually, but I'm going to do a bunch. So linear is not awesome. I'm going to leave it there. Let's maybe do quadratic, because it does seem to have a little bit of a curve here. Let's see how that one fits. Oh, that one looks pretty good, doesn't it? So let's just check out the rest. So they can do as many as they want until they come up with a decision of, oh, maybe that one's better. Let's try quartic. Let's try exponential. I don't think it's going to be logarithm. And notice that each regression gets its own color, right? And so yellow is a terrible color for graphs, so maybe we want to change the colors. So here's the regressions, and they're all on this one thing, so it gets a little confusing. So there's a couple here that clearly don't fit very well. So this one I think is the exponential, and the last one, so no, it's the cubic. So that one doesn't fit. So if you automatically know, I'm throwing those out, they're not good. All you have to do is hit trash, and they get rid of those. So now we're still working. Oh, I think I got rid of one that maybe I shouldn't have. Exponential didn't seem to fit very well. So these two seem to look okay, and there was another one in there, and I can go back if I accidentally delete one that didn't work great. I think I had cubic in there, if I was not wrong. Yeah, cubic's pretty good. So these three seem to be doing pretty well, and let's again change this not to be yellow. Let's make it purple. But as you can see, it's kind of hard to tell which one might be the best fit. They're all really close to each other. So one of the things that I love so much about Classpad is I can have all my plots here together on the one graph, but if you notice, each one is considered a separate one. So they have tabs down here. And so what I can do is click on a tab and pull them apart so that instead of seeing them all together, I think I didn't grab that right, there we go. I can see them separately. So now I've pulled apart that's the cubic one, and let's pull apart, let's take the blue one out as well. And now I can look at them separately and think, which one is the best fit for my data, right? And maybe notice that the scatter plots go away, so I could add the scatter plot back into each graph that doesn't seem to have it anymore, just so I can kind of analyze how the data is fitting. That was really nice. This one, so these are the decisions that they're going to then make, which one seems to be the best model. And then, as you notice from their questions down here, they're going to actually write that equation. So whichever one they decide is the best model, let's say we decide to go with this one, they're then going to write that equation here based on the residual. They're going to write the equation that fits that curve and answer some questions about that. And does it make sense to limit the domain or even the range? So this is where we're going, but you can separate. You can do a lot of graphs at once and separate them out. And if you want to put them all back together, all you have to do is drag them over and on top of each other, and boom, it goes right back together. So let's do that so that we have them all back together again, nice and neat. So there, I did not put it exactly. See how the dotted line comes up? There we go. So now they're all back together, I think. All right, I don't know why it doesn't. There we go. There we go, back together. Took me a while. So again, that's what students are exploring. It's really which model is going to be the best fit, and what does that model say, and then can you answer questions once you figure out a model? Can you use that model to help you answer questions about the data?